All right, so if you guys remember, we started our 11-1 notes Friday. We just need to continue with those. We really basically need to focus on that last objective. We're going to talk about the law of partial pressures and calculate partial pressures and total pressures, things like that. So we skip ahead here in the notes to get where we need to be. But partial pressure is essentially a pretty simple concept. Um, Particles of each gas are independent, so each gas exerts its own individual pressure. Basically, what this law of partial pressures tells you is that if you have a mixture of gases, each gas contributes its own pressure, but if you add all those pressures together, it gives you the total pressure of that system, of that container. So let's say I told you that you had a mixture of gases. You got oxygen, nitrogen, and carbon dioxide, and water. Right? Those four major components of the air that you're breathing right now. Right? If I told you that oxygen has a pressure, a partial pressure of, say, I don't know, it doesn't really matter. I'm just making up some numbers here anyway. Well, let's say that it has a partial pressure of 140 torr, and that nitrogen has a pressure of more like, let's say it's 500 torr. CO2 has a pressure of, let's call it like 70 torr. And then finally, the water has a partial pressure of, let's say it's 14 torr. So if that's the case, all four of those pressures contribute to a total pressure. All you have to do is add up those parts to get a total. Right? So if I added up 140, 500 plus 70 plus 14, I'm going to get an answer here. Excuse me, I kind of got a little goof there. I'm going to get a total of, what, 724. I'm using my little tablet here, and it's goofing up on me. So I'll get there. 724 torr. Right? So it's actually a fairly simple concept. It's not even a very hard concept to deal with. Right? Sometimes you'll get these parts and you have to add them up to get a total. Sometimes I'll give you a total and one of those parts will be missing. And then you just have to subtract. Right? In fact, that's actually kind of the idea for this vapor pressure part of your notes here. Right? Vapor pressure is a partial pressure. If you collect a gas over water, which is what typically would happen in the lab, you have to account for the fact that some of that gas that you collect is actually going to be water vapor. Because you're collecting it over that water can evaporate, right, at any given temperature. So some of that gas is not going to be whatever you thought it was. Say you're collecting hydrogen gas, right? But in order to figure out what the actual pressure of the gas that you collected is, all you have to do is subtract a vapor pressure that you can look up in an appendix. Right? So there are these specific pressures for water at specific temperatures. And if you just subtract those off of what your pressure is in the container, that should give you the pressure for whatever gas it was that you were collecting. So again, it's just a P total. I have this pressure that I can read in my container, but I have to realize that part of that pressure comes from whatever gas it was that I was collecting, but the other part comes from water. And so I have to subtract the water to figure out a total. So if I had this pressure in the container of 700 torr, I would subtract that pressure for the water that I would look up in an appendix, and that would give me the pressure of that gas that I collected. So maybe that pressure for water at the specific temperature that I'm talking about is 20 torr. So 700 minus 20 gives me 680. It's not really that difficult again. So you'd have a problem that looks kind of like this. Oxygen gas from the decomposition of potassium chlorate was collected by water displacement. The barometric pressure and the temperature during the experiment were 731 torr and 20 degrees Celsius respectively. What is the partial pressure of the oxygen collected? So in this problem, right, I have this total pressure, 731. Push the button again. Dang tablet. 731.0 torr. And I need to know what the pressure is of the oxygen that was collected, but I have to subtract my water vapor from that. So I'm going to look up a value in an appendix. All right, so in your book, there's a table in Appendix B in the back. It's table B8. And according to this table, and that I've just looked up here, it's on page like R63 or something like that. But the vapor pressure for water at 20 degrees Celsius should be 17.5 millimeters mercury. It also gives you a value in kilopascals, but you don't really need that, obviously. So since I have a torr value and I look up a value in the book that's in millimeters mercury, those are the same things. All I have to do is subtract 17.5 from the total that was given to me. So I have this 731. I'm going to subtract 17.5 from that. Sorry, I'm not writing very well on this tablet again. I'm working at it. But if I subtract those two values, it should give me the answer that I'm looking for. Let me grab a calculator here quick. 731 minus 17.5 gives me 713.5. So that would be my answer. That would be my partial pressure of my oxygen. Usually you just put a pressure symbol and then put the thing that you're talking about next to it. That's my partial pressure for my oxygen, 713.5 torr. So it's fairly simple, pretty easy. You're also going to be doing a worksheet for me today that has a lot of different kinds of partial pressure problems on it. So they range in levels of difficulty and things like that, but they're all really based on the same thing over and over again. Again, the whole law itself is talking about adding up parts to get a whole. But what you need to understand is that I can deal with that in a lot of different contexts. Right? I could tell you specific pressures, pressure A, pressure B, pressure C, add them together to get a total. But I could also tell you that maybe 70% of said mixture is gas A, and there are two gases in this mixture, A and B, and tell you that the total pressure is 760 torr, and just ask you what part of that pressure comes from A. And it's a very simple problem, actually. If 70% of the gas is A, it doesn't really matter what gas is which. If 70% of the gas is A, then 70% of that 760 torr comes from A. So it's a very simple problem. You can do it a couple different ways. Some people like to use a decimal for that percent and then multiply by a total, right? That total pressure is 760 torr. And if you do that, it'll give you whatever part of that pressure came from A. So 0.7 times 760 gives me an answer of 532. And I'm not really worried about rounding right now, doing this problem specifically, because I don't really feel like worrying about sig figs. 70% that I gave you before is just once, only has one sig fig in it. I probably won't want more than that in an answer like this. So it depends on the problem. You will actually round things later. But in this case, I know that 732 torr came from gas A. Now, the other thing I could ask you is, well, what part of that pressure came from gas B? If there's only two gases in that system, I could do one of two things. I know that 30% of the gas mixture is obviously B, comes from B. So I could take 0.3 times 760, but I could also just be smart. I know that it's 760 total. So all I have to do now to figure out B is recognize that, oh, hey, if 532 came from A, then I could subtract 532 from 760 and I'll get B. So this is my partial pressure for A, 732. If I just take 760 and subtract that 532, that should give me my partial pressure for B, because that's how this whole gas law started, right? Add up the parts, you get a total. So I don't know what that is necessarily. It looks like maybe 68, 168, and then 228, apparently. I don't know. I don't really feel like getting my calculator out, but I think that's correct. So it's 228 torr for B. Okay, so I can give you percentages, you can deal with that. The next thing that I can do is I can just tell you mole amounts. I can tell you that you have a mixture of A and B again, and that you have 2 moles, excuse me, of A, and you have 3 moles of B. And then tell you that the total pressure of that system again is my same 760 from before, right? 760 torr. So this time I can also ask you what part of that pressure comes from A, what part comes from B, but you have to set it up a little bit differently, right? Because you know that there's 2 moles of A and 3 moles of B. That amount actually can be turned into something that's useful, right? All I have to think about is, well, there are 2 moles of A, but there are 5 moles total. So 2/5 of the gas come from A. 3/5 of the gas come from B, right? And you can use that fraction now to set up a ratio if you want to. 2/5, right, your part over your total is going to be equal to some partial pressure, that pressure of A, because 2 came from A, over that total pressure, which happens to be 760 torr. So now you can do a fish method to try and solve for partial pressure of A. Right, so you take 2 times 760, or, well, yeah, you will, but it's 760 times 2 divided by 5. That's how You were probably taught to do that. And then you'd find out that that partial pressure for A, would be 304 torr. Partial pressure for B again could be found simply just by subtracting from 760. So I can know, right, how much that is without setting up a problem. But again, I could actually set up a ratio for that one too, because it would just be 3 over 5 equals the pressure of B over 760 torr. Right? And if you like ratios, that's what you're probably going to want to do. Otherwise, you can technically take this, get things all goofed up again. You can technically take this 2/5 from before and turn that into a decimal, because 2 out of 5 is the same as 40% or 0.4. I could actually take 0.4 times 760, and I'm going to get that same answer as I did on that last problem. I'm still going to get 304, right? It's just a different way to do it, right? And then that being said, if I go backwards, forget that line, who cares? I can do the same thing here. Maybe you don't like using decimals for percentages. You can set this up as a ratio, because 70 is out of 100 total. And you could set that up to figure out your partial pressure for A, knowing your total pressure, right, which was 760. And here I would take 760 times 70 divided by 100, which is actually the same thing as taking 760 times 0.7, so I'm still going to get that 532 answer. So you really have options. You can set up ratios, you can use decimals from percents, right? You can do whatever you need to do to get the problem done. And it's simply just a logic situation, right? Just come up with an answer, however you want to do it, right? Whether it's using fractions, ratios, or percentages, you come up with your answer and it's all good. Okay, so the last question that we could go over real quick, right? If hydrogen gas is collected over water at 20 degrees Celsius, the levels of water inside and outside the gas collection bottle are the same. The partial pressure of hydrogen is 742.5 torr. What's the barometric pressure at the time the gas is collected? This is actually a similar problem, and I got this one out of the book, so I just wanted to go over how that would work. This is actually similar to when we go all the way back here to this system type problem where you have a manometer. It said that the water levels are the same in and out, which is basically the same as if in this problem here, if you had mercury levels on one side and the other that were exactly the same. That would mean that pressure A and pressure B are exactly the same. So if I come back to this problem here, here we go. And I know that the partial pressure for hydrogen is 742.5. I want to know what the total pressure, right, is of the gas, because the total pressure of the gas would be the same as the barometric pressure outside of the system, because the water levels are the same, right? So I don't know what the total pressure is, but I know how to get it, right? All I have to do is add up parts to get a total. So this 742.5 torr is my part that came from hydrogen. I just need to know my part that came from water. So I'm going to leave that up to you. You need to find that value in your book, in that appendix B, right? What is the partial pressure for water at 20 degrees Celsius? Right? I'll give you a hint. We just used that a couple seconds ago. And you add those two things together, you get your total pressure. So hopefully that explains most of the problems that you're going to have to do. You're going to get a worksheet from your sub here. You just need to try and get as much done as you can before tomorrow. So I'll see you then.